Hello everyone, welcome back to another video. Today we're going to be looking at the Newton's questions from the grade 12 KZN 2024 paper. Question 2 reads, two blocks of masses m and 40 kilograms resting on a rough horizontal surface are connected by a light inextensible string as shown in the diagram. When a force of 200 newtons is applied to the 40 kilogram block, both blocks accelerate to the right. So I'm going to just mark that. They accelerate at 2.5 meters per second. The block of mass m and 40 kilogram block experience a constant friction force of 10 Newton and 20 Newton respectively. So I'll just make a note. So friction here is 10 Newton and friction here 20 Newtons. Again, I'm not doing definitions. Definitions are available to you. Question 2.2, draw a labeled free body diagram indicating all the forces acting on the 40 kilogram block as it moves across the surface. So question 2.2, let's put that there. So we know obviously there's going to be gravity, and since it's a flat surface, gravity is not going to have any components. So the force of gravity, it's on its surface, so there'll be a normal force pointing up. There's also a force applied, pulling it to the right. Then there is this friction force that is pulling to the left, or that will work to the left, since the object is moving to the right. And lastly, there'll be this force that's in this cable. That's called a tension force. And the tension force is not straight, it's acting kind of at an angle. So Ft. Okay, so 5 marks, 5 forces, fairly straightforward. Question 2.3, calculate the magnitude of mass m. So 2.3, calculate the magnitude of mass m. So okay, if you think about it, look at the mark scheme. It's for 6 marks. So a 6-mark question usually would indicate that you would need to do maybe a simultaneous equation, or maybe you would need to do multiple calculations. Okay? Now, since the previous question had asked us to draw the free body diagram for the 40 kilogram block, most times it means that we need to start with that. Okay? So let's see what we can work out for the 40 kilogram block. So for the 40 kilogram block, we can say that F net is equal to MA. Now we need to choose a direction as positive, and generally we would choose the direction that the object is moving in as positive. So I'm going to choose right as positive. So the forces that we're going to be interested in here are going to be the force applied, the friction, but also the horizontal component for tension. And this is the first time many of you may have seen this. Usually it's for the force applied, but in this case, the tension force is acting at an angle, so the tension force will be broken up into components. So how do we work this out? So remember, the angle theta is given here, right? Now, if we want the horizontal component, you can imagine that the triangle is complete there. The horizontal component is actually this. That's the horizontal component, and this would be the vertical component. Now, theta is here, fx is adjacent, so the horizontal component will be cos. So let's write that out. So F net is going to be FA minus friction minus the horizontal component for tension, and that's equal to MA. So we know the mass is 40 kilograms, and they've given us the acceleration as 2.5 meters per second. Let's sub in the other values that we know. We know the force applied is 200. We know the friction is 20. Then minus the horizontal component for tension. I'm calling it Tx. So x meaning horizontal and then T meaning the tension. That's equal to 40 multiplied by 2,5. We can solve for Tx now. And Tx is actually 80 newtons. Okay, so this is obviously a start, because remember the question asks for the magnitude of mass m. Now m is the other block, so we need to draw in a free body diagram for the other block. Okay, so for the other block, there's going to be gravity, so Fg. There's going to be a normal force, Fn. There's going to be a friction, and there's the tension, right? And the angle theta is here. Just like in the previous example, above this one here, the component for tension is the one that we're interested in, because remember the system is moving to the right. It's not moving up or down, so we're not really interested in the vertical components. So if we want, we can complete this triangle. We're interested in this Tx, and we know Tx, we just worked it out. Okay, so we can do F net equal MA for this block as well. So we can say F net equals MA. In this case, it's going to be Tx minus friction equals MA. Now we know Tx, we worked it out, so that's 80. They've given us friction as well. They told us the friction is 10. That's equal to the mass times the acceleration, which is 2.5. And we can solve for mass. In this case, the mass is going to equal 28 kilograms. So, as I mentioned earlier, 6 marks, could be a simultaneous, could be multiple equations. In this case, we had to do 2 separate calculations to get the final answer. Okay, let's look at the next question. So next one says the coefficient, let's go on to the next page. The coefficient of kinetic friction between the block of mass m and the surface is 0,1. Okay, let's just input this information that we got. So m is 28 here. Friction here is 10. Friction here is 20. And it's moving to the right. Okay, so they tell us now that the coefficient of kinetic friction is 0,1. 2.4, give a reason why the coefficient of kinetic friction has no SI unit. Okay, so to answer this question, let's look at the formula for kinetic friction. Fk is equal to mu k times Fn. Now, if you want to work out mu k is equal to Fk divided by Fn. We know that kinetic friction is measured in newtons, right? And we know that the normal force is also measured in newtons. So these would cancel, leaving us with no unit. So how do we put this in words? So we can say that mu k is a ratio of forces. Since it's a ratio of forces, the units would cancel, leaving us with just a number with no unit. Okay, last question, question 2.5. Calculate the magnitude of the angle theta shown in the diagram above. Okay, so to answer this question, let's look at the information that we got. We got the coefficient for mass M, for block M. All right, so 2.5, what we can do is we can start with the friction. We know the value for friction. So we can say Fk equals mu k times Fn. Okay, we know the friction for this block is 10. We know that the kinetic friction, the coefficient actually is 0.1 that was given to us, multiplied by Fn. So what we can do is we can calculate Fn. So Fn is going to equal 10 divided by 0.1, which is 100 newtons. So let's re-look at our free body diagram and then figure out what the forces are that would give us the normal force. Okay? Normally it's gravity. Gravity would equal the normal, but let's just make sure. So again, we look at our free body for mass M. We have here the normal force. We have gravity. Then we have the tension force, and we have friction here. Now this tension, as we mentioned before, acts at an angle. So it has two components, right? The first component is the x component, which we did already. This was Tx, and we worked that out to be 80 newtons, right? The other component, the y component, we don't know what that is, right? But what's important here is the following statement that we can, or the following thing that we can conclude. We can say that since this object is not moving up or down, the normal force plus the tension would equal gravity, right? So that's important, because watch what we can do. So we can say that the normal force plus the tension, well, the vertical component, would equal gravity. And now we can do a calculation, all right? This y component, if the x component was cos theta, this y component will be sine theta. So what we can do now is we can say that 100 plus t sine theta equals mg. We know the mass. The mass was 28. So 28 multiplied by 9,8. And now we can solve for this value. So t sine theta is equal to 174,4 newtons. And what do we do from here? What do we do from here? Okay, so let me show you. So it has to do with this triangle, this one here, right? Now let's look at our information. We know that t sine theta equals 174,4. That means sine theta is equal to 174,4 over t. So remember, sine theta is actually opposite over hypotenuse. So we can complete this, we can draw this triangle in. So there's theta, the angle that we want. Opposite, this is going to be 174,4, and that's going to be t. But hang on, we know the cos theta value as well. We know that t cos theta is equal to, and we work this out above, that's 80. So that means cos theta equals 80 over t. Now we know that cos theta is adjacent over hypotenuse. So the adjacent here must be 80. Now even though we don't know the value for t, we can still work out theta by using tan. We can say tan theta is equal to opposite over adjacent, so 174,4 divided by 80. Then we can say that theta equals 174,4 over 80 We put this in our calculator and we get an angle of 65,36 degrees. Thank you everyone. If you enjoyed this video, please consider leaving a like and subscribing, and see you in the next